Good morning and welcome to NASA's Johnson Space Center in Houston, Texas. I'm Sandra Jones and we are here this morning to talk about the next rotational mission to the International Space Station. That is, of course, Crew 9. We do have leaders from both NASA and SpaceX today to discuss this upcoming mission. They're going to start by providing some brief opening remarks and then we'll open it up for questions both here in the room and on our phone bridge. So joining us today is Ken Bowersox, the Associate Administrator for NASA's Space Operations Mission Directorate, Steve Stitch, Manager of the Commercial Crew Program at NASA, Dana Weigel, Manager of the International Space Station Program, and Sarah Walker, Director of Dragon Mission Management for SpaceX. So we'll first start with those initial remarks, and with that, I'll turn it over to Ken.
Hey, welcome everybody. It's great to be here today to talk about Crew 9, our next crewed mission to the International Space Station. I want to start by telling you how much I appreciate your interest in what we do. I think our work is exciting, but it's validating when I see how many of you have questions and interest in the work that we're doing. If you look at Space Station right now, we've got 5 different vehicles up there, 6 different ports with vehicles at their locations. We have never had so many vehicles and so many options. It complicates our lives, but in a really good way. But it causes us to work a lot harder as we balance everything that we need to do to get each vehicle up to station and prepare it for its return home, and we do all the work that we have planned during the mission. There are so many different constraints, so many different activities that we're trying to squeeze in. It's really an amazing job of optimization that has to be done by our commercial crew program, our International Space Station program, our international partners, our commercial partners. I can't tell you how proud I am each day as I watch them work. And if you could be in the meetings with me, I think you'd be really proud to see them as they work to make sure we get the most out of every minute that we spend with our crews in space. Balancing risks, schedules, optimizing the work on the mission, that's the job that we do every day. And we'll do that job just the same with the Crew 9 mission. We'll launch when we're ready. We'll get them up there when the time is right, and we'll do our best to make sure that we return them to Earth safely. And now I want to pass the microphone over to Steve Stitch so he can give you some more details about the mission.
Yeah, thanks, Ken. Appreciate it, and appreciate the kind words. And thank you all for being here and for your interest in human spaceflight, and also your interest in our commercial crew program. We're excited to be here talking about Crew 9 today and talking about our next crew rotation mission. And the launch date right now is no earlier than the 18th of August off of pad 39A. We have a window that goes into the early September timeframe, and that's really driven by a pad turnaround for the Europa Clipper mission. We're off 39A, and that's a Falcon 9 Heavy as well off of 39A, so that's our window. You know, we have a pretty busy time frame. Ken talked about all the vehicles that we're flying to the International Space Station. So the overall sequence is to undock and bring Butch and Sunny home on Starliner, and then go launch the Crew 9 mission, and then do the direct handover and bring Crew 8 home. So that's our overall sequence of events in commercial crew. And as you know, it's a very busy time. It's been a busy summer for us. I do want to thank our entire team across the country who've worked so hard on not only Crew 9, but all of our missions over the summer. The NASA team has been doing a phenomenal job along with SpaceX and Boeing. You know, earlier this week, it's a big activity for the crew. The crew went down to the Kennedy Space Center and got into their Dragon spacecraft. They did what's called a crew interface checkout. It's an important activity to get the crew in their spacecraft to check it out, check out the suits and the seats in their interface. They did an ingress into the spacecraft, checked out all the displays, leak checks on the suit, and all the comm checkouts on the spacecraft. So that was a big activity that went very well earlier this week. I talked to the crew earlier this week. I got to sit down with Zena and the crew, and they're very excited. They've completed all their training, and they feel like they're ready to go. And you'll hear from them this afternoon. So it's a great opportunity to hear what their excitement for the mission. And they're in good spirits and really waiting for the final phases of the hardware to get ready for flight. In terms of the Dragon status, and Sarah will give you a little bit more, but all the components for Dragon are at Dragonland at the Kennedy Space Center. We have the nose cone installed, the heat shields installed, the trunk is ready to go, and so the next big activity really is to roll over and mate the trunk and the Dragon spacecraft together. That's really the most important activity, and we'll do the center of gravity of the vehicle and then get into some of the final checkouts of the prop system. On the launch vehicle, the first stage is at the Kennedy Space Center. It's going through its checkouts. We had to work through a little bit of a challenge with some moisture intrusion during transport from McGregor to the Kennedy Space Center, and the team's working through that, and that checkout's going well. Our second stage is at McGregor, Texas. It's going to undergo a second stage hot fire around the 30th of July, and that's really to check out some of the new modifications that vehicle will have as a result of the anomaly that Sarah's going to talk more about. We have been following along step by step with that investigation that the FAA has been doing. SpaceX has been very transparent. We've had our teams embedded in the investigation and following along all the changes on that booster. So that's been an important activity we've been doing. The crew will be flying aboard Dragon Freedom. That'll be its fourth flight. It flew on Crew 4, Axiom 2, and Axiom 3. And while we're here talking about Crew 9 today, I would like to announce that Crew 10 will be flying in February of 2025. That's the next flight, in order to give a little bit more time for Starliner to complete the mods after CFT. So Starliner 1 will move into the August slot next year, and we'll be double booking that slot with Crew 11. We're really excited to be here. It's exciting to be working so many things in Commercial Crew. I have the honor of leading the best team at NASA, and it's an exciting time frame, and I'll turn it over to Dana.
All right, thank you very much, Steve. Thank you all for being here. Appreciate the interest that you have in this upcoming mission and also in the ISS mission as a whole. Let's see, as you know, Crew 9 will spend about 6 months on board. We've got 2 new flyers going up. We've got NASA astronaut Zena Cardman, and we've got Roscosmos cosmonaut Alexander Gorbunov. For Nick Hague, this will be his second flight with us. He did another expedition previously on board. Stephanie Wilson is flying for the 4th time, but this will be her first long-duration mission. So really excited to have them on board soon. While they're on board, they'll spend a significant amount of their time conducting scientific research. Got a wide range of experiments. Some of the highlights, some of the things they'll be doing, studying the behavior of intermittent or non-steady flame spread. We're interested in studying that because we don't have great ground models today that help us predict how wildfires spread. That's one of the big challenges we have. We're hoping to leverage what we can learn on board without the effects of gravity to improve our ability to predict what our wildfires here on Earth will do. The crew will spend some time studying cell changes, cell morphology, and gene expression changes for cells that have been exposed to long-duration spaceflight, hoping to increase our knowledge on the impacts to the human body when we do longer and longer missions. We'll also be looking at the physics of neutron stars, and the list goes on, but those are just a couple samples of the types of things that they'll be doing on board as they're conducting research. Of course, Butch and Sunny, have been on board. They're enjoying their time, and we're making great use of the extra helping hands. They've conducted a lot of extra research for us as well. Looking forward, we've got a busy time in front of us with vehicle traffic. We are working towards a Northrop Grumman Cygnus launch on August 3rd. That vehicle will berth on the 4th. After that, the week later, we've got a Roscosmos Progress cargo vehicle that's scheduled to launch on August 13th with the docking on the 15th. As Steve mentioned, hot on the heels of that flight, we've got the Crew 9 launch, a Crew Exchange, Crew 8 coming down. And then looking forward in September, we've got a Soyuz crew exchange. 72S is launching with NASA astronaut Don Pettit, and then 71S will come home, returning Tracy Dyson. After that, we've got a Dragon cargo mission, that's SpaceX 31, that we need to get up there. And then we've got a handful of spacewalks that we're still working to fit into this overall busy plan. If you recall, on June 24th, we ran into an issue with the spacewalk and had an early termination when we found a water leak in one of the umbilicals that feeds the suit. We've since addressed that. We've swapped out that leaky umbilical, and now we're just working to find time in the busy schedule to replan that series of EVAs. My expectation is that's out in the fall timeframe sometime, so we're still working through that. So as always, as Ken said, very, very busy on board ISS, very busy summer, and we've got a very busy fall, and we are really looking forward to having Crew 9 on board with us. And with that, I will pass it over to Sarah at SpaceX.
Hi, thanks for having me here today. SpaceX and NASA teams, as Dana and Steve have mentioned, have been busy preparing for the Crew 9 mission this coming up next month. Crew 9 will be our 4th Dragon mission this year. We previously launched AX-3, Crew 8, and Cirrus 30, and it'll be our 45th Dragon mission to the space station. You all know human spaceflight is core to SpaceX's ultimate mission to flying crews safely, or to making humanitarian interplanetary, and flying crews safely is always our top priority. So on Monday, Steve was talking about what we call the crew equipment interface test. We like to refer to it as the Dragon test drive of the spacecraft because it is the first time that the crew gets to step into their flight vehicle rather than a simulator. It's a good opportunity to do final suit-to-seat connection checks, audio, environmental controls, and more. But for me, it's a moment when it really sinks in that their journey to space is just around the corner because they're getting into their final flight vehicle. So as always, we will step through final launch preparations over the next few weeks. We'll fuel the spacecraft, we'll transport it to Hangar 39A, we'll mate it to the Falcon 9, and then roll it out to the pad ahead of dry dress activities, integrated static fire, and finally liftoff. So speaking of liftoff, the new Falcon booster that's supporting this mission is at the hangar, as Steve mentioned, and is nearing ready to fly. As many of you know, about 2 weeks ago during a Starlink mission, Falcon 9 first stage performed a nominal first burn, separated from the second stage, and returned for a successful landing. However, a liquid oxygen leak developed in the second stage engine. So the cause of the leak, I mentioned that this happened when I spoke with you guys last week, but I have a bit more detail to share with you today and some good news. So the cause of the leak was later identified as a crack in a sense line for a pressure sensor. So this line cracked due to fatigue that's caused by engine vibration and looseness in the clamp that constrains that line. We found it really interesting and positive that despite the leak, the second stage engine still continued to operate throughout the entire duration of that first burn where we observed the leak. It completed engine shutdown and then it entered a coast phase for about 30 minutes in the intended elliptical parking orbit. So the Starlink satellites are initially inserted with the second stage into an elliptical orbit with a low perigee and a high apogee. And then after about 30 minutes, we perform a second burn to circularize at the higher altitude. So unfortunately, the fluid leak that we saw in the first burn in the cold of space led to excessive cooling of the engine components, and most importantly, those associated with delivery of the ignition fluid to the engine. So when it was time to restart the engine for the second burn, it experienced a hard start because there was slow delivery of that ignition fluid to the chamber. That damaged the engine hardware, and then it caused the upper stage to lose steering capability. So these are things that we think about in the design and build of these vehicles. So the second stage itself continued to operate as intended in a scenario like this. So what it did is it proceeded to deploy the Starlink satellites and then successfully passivate itself. That's a process where it vents down stored energy in the stage, which that occurs at the conclusion of every Falcon mission. So in other words, the stage sensed that there was something wrong with the engine. It went ahead and did its payload deploy sequence and then passivated itself to safe it for deorbit. So For the near-term Falcon launches, we actually just removed this sense line and this sensor from the second stage engine. It's not related to the flight safety system in any way. It's not used for that system, so we're able to just remove it. It's redundant with alternate sensors we already have present on the engine, but that location tends to see a bit more vibration. So we can get the same data from our other sensors. We just pulled that line out of the engine for the near term. And that design change has actually already been tested at our rocket development facility in McGregor, Texas. So Steve also mentioned that our teams have been performing this comprehensive review with the FAA as part of the formal investigation process, but also of all of our SpaceX vehicles and our ground systems, including Dragon. So we wanted to ensure we've been meticulous and thorough with what we've learned as we return to flight. And I have good news to report, which is that yesterday the FAA formally approved us to return to flight, that they agree with the conclusions of our investigation and the corrective actions taken, which is really good news. We actually expect Falcon 9 to return to flight this evening, launching from Launch Complex 39A in Florida. So it was really incredible to see how quickly the team was able to identify the cause of the mishap and then associated corrective actions to ensure success of future missions. So shifting gears, I know when I was with you last week, you were asking about this topic of trunk reentry or trunk demisability. So shifting gears, I'd like to share some exciting updates we have planned for Dragon there too to address those recent findings. So after 5 years of splashing down off the coast of Florida, we've decided to shift Dragon recovery operations back to the West Coast. So that's where we recovered the Dragon cargo spacecraft 21 times between the years of 2011 and 2020. And we will be sharing more detail associated with this on our updates page later today, but I wanted to provide you some insight ahead of that since we are here together. So when we were developing Dragon's current reentry operations, which we've used for all our crew missions and then cargo missions since CRS-21, SpaceX and NASA engineering teams use these industry standard models to understand the trunk's breakup characteristics. And they predicted the trunk would fully burn up due to the high temperatures that are created by air resistance during that high-speed reentry into Earth's atmosphere. They should leave no debris. And that was a determining factor in our decision to passively deorbit the trunk and enable Dragon splashdowns off the coast of Florida. So today, Dragon's trunk is jettisoned prior to the vehicle deorbit burn while still in orbit. That leaves it in space while the capsule comes down and does a pinpoint splashdown, and then it passively re-enters and breaks up in the Earth's atmosphere in the days to months that follow. Because the trunk doesn't have any maneuvering capabilities of its own after separation, the location and the precise timing of that trunk reentry can't be predicted. It's dependent on solar activity and atmospheric conditions and a number of other things. So to date, of the new Dragon trunk and operational concept that we've been flying since, I think, 2019 or 2020, to date, the majority of that trunk debris has re-entered over unpopulated ocean areas. But the fact that any debris has re-entered indicates to us that we need to draw a different conclusion from that initial analysis. And so I just want to say that we are committed to safe spaceflight operations and to public safety. It's at the core of what we do. So after we first discovered this, I believe it was back in 2022 when a piece of trunk debris was found in Australia. We quickly worked to make some immediate changes that could be implemented quickly to improve our probability. But then we also launched into a big effort to work with NASA and the FAA to pursue a longer term solution. And that's where we are today with this move back to the West Coast. So what we'll do is we'll implement a software change to complete the deorbit burn before jettisoning the trunk, like we did with Dragon 1. And then the trunk will intentionally land safely uprange in an unpopulated area of the ocean again. So to make this change possible, we'll move a Dragon recovery vessel to the Pacific sometime next year. And we'll use SpaceX facilities in the Port of Long Beach for our initial post-flight processing. Then Dragon will be transported back to Florida for preparations for its next launch. So I do want to say this isn't just going back to the old way of doing things, especially considering our human spaceflight recoveries have never before been executed from the West Coast. So instead, I see it more as taking a familiar operations concept and applying it to the Dragon we fly today, finding a way to combine the public safety benefits of West Coast recovery with all the benefits of crew transportation services and enhanced cargo return capabilities that we provided the last 5 years out of Florida. So continued innovation of spacecraft design and operations. This is critical to ensure Dragon continues to safely fly to and from Earth orbit. This new path, I believe, will make it possible while also keeping the public safe as we work towards becoming a spacefaring civilization. So again, I encourage you to keep an eye on our updates page for even more information. I think it will be posted later today. I do want to note, since this is a Crew 9 mission briefing, that the Crew 9 mission will still splash down off the coast of Florida as our teams are working to fully transition this entire operation over to the West Coast. And we hope for that to be complete shortly after Crew 9's return. So all of these updates, the rapidly solving the root cause of the stage 2 issue a couple weeks ago, finding safe solutions for Dragon trunk recovery in response to new information, I really think they're all a testament to the relentless, creative, hardworking, agile, vigilant teams here at SpaceX that I'm proud to call colleagues and friends. So on behalf of that team, I can say that all of SpaceX is excited and ready to launch Crew 9 safely to the International Space Station and support all of the incredible science and research they'll conduct throughout their mission. Thanks for including me today, and thanks so much to Dana, Steve, Roscosmos, NASA, everyone for your trust and your partnership. I'll see you in a couple weeks for launch.
Thank you to our briefers for those initial remarks. We are going to open it up for questions now. I'm going to start with a couple here in the room if we have them before jumping over to our phone bridge. If you are on our phone bridge, please press *1 to submit your question. If you find your question has been asked already, you can press *2 and you can withdraw it. Once your name is called, please do state your name, affiliation, and to whom you'd like to direct your question. And if at all possible, try and keep it to one question so we can get through as many as possible today. I'll start here in the room.
Oh, thank you, Mark Carreau with Aviation Week and Space Technology. My question has to do with the Falcon 9 second stage before you launch the Crew 9 mission with astronauts. What will NASA do to certify or make sure that the issue that arose a couple weeks ago has been dealt with in a way that meets your safety standards? Thank you.
Yeah, thanks for the question, Mark. We've been following along all the way through the investigation, so we agree with everything that Sarah talked about. We understand the root cause. The root cause was really this sense line that she talked about that was potentially a little under-designed, I would say, for that environment. So what we're going to do on our stage is exactly what Sarah talked about. We will cap that sense line, and we'll remove that pressure transducer that's measuring the liquid oxygen pressure in the pump, and we'll go through a rigorous certification of that. So we're going to look at all the changes to the flight software that now won't utilize that sensor. We're looking at all the hardware changes associated with that. We understand exactly what they've done relative to that change, and so we'll go through that and take it to the program control board, and we'll baseline that change for a Crew 9. The beauty of what they've done is we'll get, hopefully we'll get the Starlink mission that Sarah talked about off this weekend, and we'll probably get another couple flights in there before ours. SpaceX has made this same change on a very similar second stage to ours that's already been through testing at McGregor. We followed that testing, and we'll follow the same testing on our stage. So we'll get a check of that sensor in this second stage test, like I spoke on the 30th. So it's our process for dealing with changes, and we'll work through all the data, work through all the analysis and certification, and then we'll be ready to go fly.
Thanks, Steve. We'll do another question here in the room. Go ahead.
Hi, yes, Will Robinson-Smith with Spaceflight Now. Appreciate y'all taking the time to talk to us. Question, I believe, for Steve and Sarah, if she'd like to join in. You mentioned the timing of Crew 9 needing to happen within a certain pocket to transition over to the Falcon Heavy configuration for Clipper. I wonder, is there still some outstanding work or validation that needs to happen with the crew tower over at Pad 40? And just wondering why that wasn't used as the primary for Crew 9 so that there wasn't a potential conflict. Thanks.
Yeah, good question. We've been working really hard on the certification for Pad 40, and we're close. We've tested the crew escape system. We've tested all the pad systems, but we're not quite complete on certification. If we were, we would entertain moving over to Pad 40. So that's probably a little bit more like late September timeframe. So we just sort of missed this window together with all the work that NASA and SpaceX had on our plate. We just didn't quite get there. So that's why we're going to fly off 39A.
Okay. Another
Yeah,
question
and
here in the.
I'll just
Oh, I think Sarah wanted to jump in if that's okay. Then we'll go to you, Gina. Thanks.
Yeah, I'll just chime in really quickly that yeah, I agree with everything Steve said. So the pad 40, the build itself, the preparation of the pad is complete. You may remember we launched CRS 30 off of that mission, but then there's a joint certification effort specifically for human spaceflight missions that we do in partnership with Steve's team, and we've been working through that process to make sure all the T's are crossed, all the I's are dotted before we would fly a CCP mission off of Pad 40. I think we could have done it by this mission. We're nearing completion, and huge thanks to Steve's team for all the hard work there. But we have several weeks of runway on 39A. The Clipper mission is in October. It does take us a little bit longer to convert the pad to the heavy configuration, but I wouldn't say that we're running out of time or that there's not enough room to launch Crew 9 when it needs to be launched. And then I wanted to go back to a previous question really quickly, perhaps maybe some helpful context. Is that the issue that we observed on the Starlink mission two weeks ago actually wouldn't have occurred if this were a Dragon mission, because the first stage and the first burn of the second stage actually completed the mission exactly as intended. It was something unique about the mission profile of that mission where we coast for a long time. It's very cold in space, and that small leak, while it didn't affect the burn, did make the components where that liquid was present get really cold. And so we never assumed that an issue is isolated, while that issue would not have occurred had that been a Dragon mission, because there is not a second burn or that coast period. We still use that to launch into an audit of every system on that vehicle and every other vehicle. So we did do that scrub, but I thought it might be helpful context that this issue was a little different than what we would see on the mission profile of a Dragon mission.
Thanks, Sarah and Steve. Okay, Gina, go ahead.
Gina Sinceri, ABC News for Dana. For the cargo mission, the Cygnus flight that's going up, tell me about the critical cargo that's going up. We're kind of missing that briefing. It's the same time as this, right? And are any of Butch and Sonny's belongings that they had to take off for the pump going to make it to them before they come home?
Yeah, great questions. As you know, on every single flight we fly, we've got a lot of critical things. There are basics on board, food and water. We have that almost every flight. Crew supplies, research. In terms of some of the unique things that we're flying, we have a couple, what I'd call critical ORUs. You know, we tend to, on board, spare the vehicle with one spare critical component for each item. And so when you have a failure of that, you got to resupply it. So the couple things that just stand out off the top of my head, I do have another one of the urine pumps that we had talked about previously that we had problems with. In fact, the one on orbit's acting up a little bit. The one we had to quickly fly on Starliner was a more immature design, a shorter term unit. This is our longer term legacy, very robust unit that I've got flying up on NG-21. We've got a couple other things, like I've got some navigation sensor replacement, hardware, a docking reflector replacement, a couple things I need for some of the other EVAs that we had originally planned to do in the fall. In terms of items for Butch and Sonny, we did go ahead and put, since we took their suitcases off their previous flight, I had some things loaded here early on. We had to make manifest decisions very early, and not knowing when things would line up. We did put some things on there which can also be used generically to backfill the generic supplies. So there are a few things, not a lot of really super crew unique items, but a couple things to help backfill.
Thanks, Dana. All right, we'll head over to our phone bridge. We have Bill Harwood with CBS News.
Thank you very much. A real quick one for Sarah. Are you saying that the FAA has cleared SpaceX to launch, period? Or is there anything outstanding you guys have to do in regards to licensing before Crew 9 can fly? And I'm sorry, I got to ask the second one for Steve. You mentioned how you follow along in lockstep with SpaceX when there's a failure investigation like this. Can you give us a little more detail on exactly how you do that? Is there any hands-on work that NASA or its contractors do to verify what SpaceX is saying? I mean, I'm not challenging that. I'm just saying, or is it just you guys just reviewing the data that they present you to conclude that everything's okay? I'm just trying to understand better what depth of oversight NASA has into recovery from an anomaly like this. Thanks.
Sure, I'll speak for a minute. So Yeah, so there is a standard licensing process for every launch where we have to submit licenses and be approved. And so that's still ongoing like every mission. But specific to the issue that we saw, yes, the FAA has given us their final determination, which means in all of the daily briefings and digging through the data that we did together with the FAA, and that's actually something that NASA officially has a seat at the table to participate in all of that. We stepped that process. It's formally defined by the FAA when stuff like this happens, and we stepped through that process. We submitted our data. We had a Q&A period where we exchanged more data, and then they've given us the final determination yesterday that they agree with our conclusions, and we are ready to return to flight. So I know Steve mentioned that they will also have a board meeting to gather their teams and review that data, communicate, and make sure that all the NASA teams are ready to fly as well. But from the FAA perspective, we're ready to return to flight.
And I'll take the second part of the question. You know, in any investigation, NASA can do additional analysis, additional tests. It really depends on the nature of what happened, the nature of the anomaly, how much additional testing we will do. I would say in this case, what we did was we participated in the development of the fault tree. We reviewed all the telemetry that SpaceX went through to determine the root cause, the video analysis that they did to determine the root cause. We went through all that with them, all the testing that they had planned to do to show that this was the potential cause of it. In fact, SpaceX actually went back and looked at some, the stage that flew on the Starlink flight. There was actually some signature maybe in a test at McGregor that could indicate that there was a potential problem there. We sat down and reviewed all that data with SpaceX. So this one was more of a working side by side with SpaceX and looking through everything that they did and all their corrective actions. I would say SpaceX went above and beyond the specific cause of this particular sense line issue. They went and looked across the Dragon vehicle. Are there anything like this on Dragon? Also on the first stage of Falcon 9, is there any other P-clamp or sensor that's just like this? So we really followed along and looked at all the data. In this case, because SpaceX did such an extraordinary job, we did not go do any additional testing or analysis. We didn't feel like that was required. So.
All right, our next question on the phone bridge is from Jeff Faust with Space News.
Dragon manifest. I know before the Falcon 9 anomaly, you were tracking a launch of the Polaris Dawn Crew Dragon mission around the end of this month. Where does that fall in the manifest now, and is that a potential candidate for launching from Pad 40 while 39A is in the Falcon Heavy configuration? Thanks.
I think that's a question for you, Sarah, but I can answer if you would like. We still have Sarah?
Oh, sorry. Can you hear me now?
Yes.
Okay, great. Yes, we are in final preparations for Polaris Dawn. We are so excited about that mission. We're still holding a late summer slot, and I think this is just kind of evidence of the great partnership across all of our NASA missions and all of our commercial customers to ensure that we fly each mission when the time is right. And so there's a lot going on ISS right now. We opted to fly the Crew 9 mission as our next mission, and are ready to fly Polaris Dawn late summer as soon as we fulfill those obligations.
Thank you. All right, next up is Micah Maidenberg with the Wall Street Journal.
Hey, good afternoon. Sarah, just regarding the second stage anomaly, the recent one, presumably the sense line worked in the past and many times. So again, could you just help me understand like why this issue came up with this particular flight? I know the company statement mentioned engine vibration and looseness in a clamp. Like what caused that? Was that something on the ground at SpaceX, or was there something different with kind of the ascent and operations for that Starlink mission? Thanks a lot.
Yeah, I'll say that the only unique thing compared to the other flights is this location actually had two connections instead of one, which was driven by actually a customer requirement on another mission, not a NASA mission, and we left it in that configuration for this flight. So yeah, we are looking into that. I think there's a little nuances about how this line is attached. It's in a location that is a bit more susceptible to vibration as this rocket gimbals and fires. So a small crack developed in this case, and then a small leak of liquid oxygen. This is an area where from the main chamber, some liquid oxygen is allowed to come through the line so that the sensor can then measure pressure. And so that little bit of oxygen that came through formed a small crack. A bit came out, and then that in the cold of space over about 30 minutes made that line so cold and a couple lines around it that we weren't able to deliver the other fluids as quickly as we needed to start up that engine for the second burn.
And I'd like to add a couple things. I mean, I think this is great evidence, and what I told our team of, like, you think about the big things on a rocket. You think of the big gimbals that move an engine. You think about the turbo pump. Think about the flight computer and things like that. But this sort of shows the attention to detail that's required in space flight. Essentially, SpaceX made a small change to a different transducer. There was an in-house transducer pressure measurement for this particular sense line attached to the sense line, probably not knowing exactly how sensitive this area was to vibration, and how the insulation was attached and how this clamp was attached. And then they removed the clamp, and so they did analysis on that, and it looked good. But the combination of those factors, the kind of material that was used, removing the clamp was important, and kind of even the way the tubing was made was important. So what I've found and what SpaceX has found here is it was a small change that you would think would be innocuous, but that I think is a good lesson learned for all of us in human spaceflight and in spaceflight in general, is small changes matter. And we had looked at the change, and we didn't see any problem on the NASA side as well. So SpaceX has done a great job of going back and looking at this area and then any other areas on the vehicle that could have a similar problem, where you did a qualification by a little bit of similarity to what you had before, but maybe without having quite the thorough testing that you should have. And so I think that was a great lesson learned for all of us.
Next up, we have Jackie Waddles with CNN.
And thanks for doing this. A quick follow-up question for Sarah. So I just want to make sure I understand, too. How do we know for certain that a problem like this couldn't arise on the first burn? I know you mentioned this wouldn't affect a Dragon mission. For that reason, it was only the specific flight profile. But was there any steps you took to ensure that a leak like that couldn't cause a fuel issue earlier in the flight? And then also, just really quick, if you don't mind, could you kind of lay out SpaceX's overall Falcon 9 flight profile ahead? Just wondering where Polaris Dawn might land on the schedule now. Thanks so much.
Hey, yes. So your first question was about are we sure that this is isolated to the specific line and the specific sensor? That's exactly what that root cause process. Steve described the fault tree. That's exactly what we do. That's what the FAA investigation is intended to do. Is you start with a list of every possible cause that could have caused this to happen, and you slowly drill down using flight data and telemetry to eliminate or exonerate. No, this isn't a possibility because of this. This one's not a possibility because of that, until you get down to the most probable cause. Or in very clear cases, we were really lucky this time to have a ton of data. The stage we were talking to it and receiving data throughout this entire time, all the way through passivation. And so we had a lot of flight data to work from to see really clearly the timing of everything and the locations of everything. And so, yes, we do not just consider the issue that happened to be an isolated issue, but use that to then kick off corrective actions for that system and look into every other system that might have the same vulnerability. I think maybe one other thing I wanted to go back and address from the previous question about configuration. I think this is maybe an example of why SpaceX really feels strongly about testing like you fly, and then also flying regularly, so that we get a lot of flight heritage and history on our hardware and know how it works in every situation. So sometimes we need to fly a really unique mission for a customer that drives a necessary configuration change to the system. But the number of times we're launching in a year, we want to take credit and have the data from every one of those previous launches to inform the next one. And so that's why we hold as tightly as we can to making every vehicle still the same, so that it's the same body of data and we know how it flies because we've done it a lot before. So I thought that was an important thing to mention as well.
Thanks, Sarah. Next up is Joey Roulette with Reuters.
Thanks, Sandra. For Steve, I just wanted to follow up on your remarks about Starliner. Is having the astronauts, Butch and Sunny, return to Earth in Starliner required for Starliner certification?
Question relative to Starliner, we would like to return, as I've said, our prime option on the crewed flight test is to return Butch and Sunny on Starliner. We would like to get all that data for certification. The importance of returning them on Starliner really is to look at the suit-seat interface, how the crew interacts with the vehicle during the deorbit burn and entry, and then the recovery operations as well. We've recovered cargo from the 2 uncrewed flights that we've had. Now it's a little different with crew, right? You have a crew on board, and the ECLS system has to work a little harder during entry with those crew loads, and then at recovery, demonstrating that whole end-to-end process of getting the crew out of the vehicle, how the landing and recovery team interacts with the vehicle, and then that is important for us for certification.
So is that required, or is that something you guys just want?
It's something we would desire to have. We would have to talk about, if we didn't have it, would that be we would meet all the certification requirements? So.
Our next question is from Stephen Clark with Ars Technica.
Hi, thank you. I think my questions are probably for Sarah. Just to clarify from your statement about shifting Dragon recovery ops to the West Coast, is it your intention to shift all? You mentioned moving one recovery ship, so will all Dragons be splashing down off the West Coast, or will you still have Florida as or the Gulf or the Atlantic as an option? And just refresh my memory on the reasons for initially splashing down off of Florida, and what do you give up in terms of turnaround time, or I guess doing the deorbit burn with the trunk? You presumably need to consume more propellant. So what do you give up in terms of performance by making this change to the West Coast? Thanks.
Sure. Yeah, thanks for your question. So yes, we do want to move all Dragons to the West Coast. There may be a small transition period as we're moving vessels through the Panama Canal from East Coast to West Coast, where we can support either coast. Our kind of FAA trajectory deliverables will all include past and present sites. And so we similarly did that with Dragon 1, I believe. Let's see, we moved we flew the Demo 1 mission, a crew mission, out of Florida in, I believe, 2019 before our last cargo mission on the West Coast in 2020. And so we may see a similar transition period as we're moving all of the hardware and facilities and infrastructure. But yes, we will eventually land all Dragons on the West Coast. We have launch pads on both coasts, and we also have Falcon recovery operations. And so those, by nature of the flight profile, will remain on both coasts. The booster will land on the coast where it launched. So we'll still have recovery operations in Florida, but all of Dragon will be on the West Coast. And then I loved your question about what do you give up? Because you're right, when we were developing our new concept of operations, NASA gave us new requirements, starting with CRS 21, for even tighter return timelines, enhanced science capability, and that was all factored in when we were designing and building the whole system in Florida. And so that's the new challenge ahead of us now, and what we've been working through here this year is how do we come back to the West Coast but still maintain all of what we've learned and stood up to support crews, not just cargo, in terms of quick return to handover for NASA, support of possible contingency situations, and how do we keep even faster cargo handover timelines than we did for Dragon 1. And so, yes, we're working through all the details of that, but it will be a better capability than we had back in Dragon 1 by design. And that's the problem space that we're solving right now, is how to do that here on the West Coast when we had initially designed it all in Florida.
Our next question is from Elizabeth Howell with space.com.
Thanks, everybody, for taking the time. This is for Dana. And so until the suitcases get up there for our CFT astronauts, how are you working on resourcing them, especially for things like clothing or food or any other consumables that you were thinking were going to be more like a 10-day mission and less like a 50 or 90-day mission? Thanks.
Yeah, there are any number of challenges that we can face that result in a shortage of supplies on board. For example, if you have a cargo flight that slips out. And so the way we deal with those risks generically in the program is we keep what we call a contingency reserve on board. In general, that's about a 4-month supply. That applies to things like food, water, oxygen, nitrogen. And so we keep a buffer, and we do that for crew supplies too, things like clothing. And so we had plenty of generic supplies on board, so we just had Butch and Sunny use those. And as I mentioned before, we'll replenish some of those generic supplies on NG-21 and then also on the upcoming SpaceX 31 Dragon cargo flight. But we keep that reserve level high enough so that we can deal with any number of different contingencies or uncertainties.
Thanks, Dana. Next up, we have Jonathan Suri with Fox News.
Thanks so much for doing this, everyone. My question is for Dana. Is the Crew 9 launch contingent at all on the return of Starliner, or would ISS be able to accommodate everyone if the missions were to overlap for a few days?
The biggest issue for us is the number of docking ports. We have 2 docking ports on the vehicle, and Starliner and Crew Dragon both require docking ports. We have other cargo vehicles that use our berthing ports, but these crewed spacecraft only use the docking ports. So right now, the configuration on board is Crew 8's got 1 docking port, and Starliner is on the other docking port. They're on the Node 2 forward port. And so in order for me to send up Crew 9, I've got to take off a vehicle. And so our plan is to undock Starliner first, free up a port, and then we'll send up Crew 9. So it's not really about overlapping crew members in terms of a constraint on board. It's the number of docking ports we have at this time.
Our next question is from Jim Siegel with Florida Media Now.
Hi, everybody, and thanks for taking my question. I'm particularly interested in activities related to growing food in the ISS and beyond in longer-term flights. Are there any such experiments, new experiments planned that are going to go up either on Crew 9 or on the Cygnus flight? Thank you.
I'd have to look at the specific manifest, and I can get back to you on that, but I will just make kind of a generic comment that we've got a couple of different facilities that we use. We've got one called Veggie, and we've got an advanced plant habitat, and we tend to keep those pretty busy. The cycles for growing and how long it actually takes to grow out seeds, sometimes we have to adjust and flex, but those are often pretty highly occupied facilities. During harvest time, it gets pretty exciting for the crew on board. In the past, we've had tomatoes, we've had chili peppers, and the crew always wants to eat them, and so we have to share some of them with the scientists and some of them with the crew. And so those are always really exciting opportunities. But we'll get back to you and see what we have on the manifest and what's around the corner for plant growth.
And Jim, we have a couple products that will be released soon that go in depth on the science launching on Crew 9 as well as on NG, so I'll be sure to pass those along. All right, next up we have David Nault with About Today News.
I want to come to the question again about the Polaris Dawn mission. Sarah, when was the decision made to pull the mission from the August 31st? And last I checked, it was still on their site for launch. When was that pulled? And how late in the summer would you think this would go? Would you think into late August or September?
Yeah, thanks for your question. I do think that it went to the range to change the launch date for Polaris yesterday. No? Okay. It's all happening this week is the bottom line. What we did is we pre-planned rules of engagement between the 2 missions to make sure that both customers could fly in the right time. Number of days for weather, number of days for each operation, for pad turn, all of that stuff. And so we've been working with both customers. Right now, we're still protecting for an August launch of Polaris Dawn. And so, yeah, I guess that was your question, August or September. Right now, we're still planning to launch Polaris Dawn in August. And And yeah, and then I also wanted to circle back to a previous question about West Coast and East Coast. I forgot to mention one benefit of moving to the West Coast is much better weather. So we have a number of sites in Florida that we feel like we're sometimes threading hurricanes a lot. And when we looked at the flight rules for wind, rain, wave height, all of the criteria that determine our flight rules for return, we actually saw that the West Coast sites that we're looking at have much better weather, which allows us to have much better return availability. So that's one thing, just to go back to the previous question, that we're looking forward to.
Thanks, Sarah. Next up, we have Douglas Gorman with Payload.
Yeah, hi. Thanks for taking my question, being so transparent about all of the changes. My question is about the anomaly. So I know, Sarah, you said that you would be taking out the sensing line that caused issues on the last Falcon 9 launch. What do you lose from having that sensing line on? Is there going to be less data on future launches? If you could just explain, more of what's going to be missing from that data.
Sure. Yeah, that's a great question. Most parameters that we're watching in flight, we have 2 or 3 or more redundant sensors. And so I mentioned the near-term action was to just remove that line. That's actually a good point that maybe will be a helpful clarification. So while the FAA investigation is complete, what that means is we know what caused the problem. We've looked at all of the systems to ensure separation, and we've agreed to a set of actions to take going forward. That doesn't mean that all of the actions have been taken yet. And so I think we'll just remove this one sensor from the data set for the near term so that we can fly with all the sensors that we have. And then there's further steps to continue improving the fleet as we go on.
And I would add, from a commercial crew perspective, for us, that sensor is more critical for some of the more aggressive flights that SpaceX flies that require multiple burns out of the second stage. For us, we have one long burn after first stage to get the vehicle Dragon inserted into orbit. And so for us, the sensor isn't as critical. It helps with a little bit with determining the next burn and how the next burn will be executed.
Thank you both. Next up, we have Ryan Catan with NSF.
Hi, thank you. This is for Steve. Does NASA have to approve next week's Starliner readiness review before the crew plans for Crew 9 can be finalized? That's assuming, based off the information in the presser yesterday, that Crew 9 could be considered for a backup return vehicle. Thank you.
Yeah, we're really working toward readiness review for the Crew 9 for CFT return at the end of next week. Hopefully, we'll get through that, and then we'll proceed into the rest of the manifest with the Crew 9 launch and then the Crew 8 return. So it's a pretty busy time for commercial crew. It's a pretty busy time for Dana, but we're working through the Starliner investigation, getting through the final, as I talked about yesterday, the final parts of that investigation, and then heading into the agency readiness review.
Thank you. Our next question comes from Stephen Clark with Ars Technica.
Hi, thank you. I just had a quick question on the manifest for the rest of the year, Dana. You didn't mention AX4. Where is that going to fall? Is it now next year? Thanks.
Yeah, we're still holding that flight no earlier than November, and so of course we'll adjust if we need to as we look at the manifest and where things really lay out, but for now we're just holding it there.
Thank you. And we do have another question here in the room.
Hi, Will again with Spaceflight Now. Believe question for Sarah and perhaps Steve as well. I think it was Bill Gerstenmaier that said last year that the next Crew Dragon spacecraft would be brought into the circle this year. It seems like that's not happening. Is that still on tap for this year or perhaps next year? If you just clarify that, thanks.
Hey, yeah, that's not the Dragon that we're using for this mission, but it's almost done. And so I'm not sure if it's late this year or next year that it will be a full-fledged member of the fleet, so to speak. We'll have 3 cargo vehicles and 5 crew vehicles at that point. But yeah, it's nearing completion. can't remember if it's still in our Hawthorne facility, or if I think it's still in our Hawthorne facility in the Dragon clean room. But it'll be moving to Florida shortly for just final preparation for whatever mission it gets assigned.
Yeah, right now, I mean, that Dragon is at Hawthorne. It's getting assembled in the clean room. It's going through its final preparation. Right now, it's slated for Crew 10 in February. So we'll have it's exciting to have another brand new Dragon spacecraft for Crew 10. That's the plan right now. So.
Thank you both. We have Bill Harwood with CBS News next.
And this is for Sarah, I think. Just out of curiosity, I'm not sure I understand what an engine hard start means in this context. Did the engine break up? I mean, was the stage still intact after that? I know you lost attitude control, but what exactly happened when the hard start occurred physically to the rocket? Thanks.
Sure. So while the propellant and liquid oxygen were flowing to the chamber, there's a third thing you need, an ignition fluid called TTEB. I mess up if I tried to say the names of those chemicals in public, but TTEB is the ignition fluid that comes into the chamber. And it moved through its line because it was too cold, too slowly. And so without that ignition fluid present at the time when the fuel and the oxygen started mixing, that caused damage to a number of components on the engine. It was not widespread damage to the entire stage itself, as we saw by the stage still continuing to send telemetry throughout the whole operation, deploy the satellites, passivate itself. But there were a handful of components on the engine that were damaged, which did not allow it to complete that second burn.
Our next question comes from Jeff Faust with Space News.
Quick follow-up question for Sarah. You mentioned removing the sense line as a near-term fix. What are you looking at in terms of a long-term fix, and how far long-term might that be? Thanks.
Hey, I think that the full report from all of our work with the FAA in the last 2 weeks is coming out. I think it's made public very soon. So that'll have a ton of details in it. But I think there's a number of actions that will be coming up for us in the coming weeks.
Thanks, Sarah. And the last question we're going to take today is from Joey Roulette, again with Reuters.
Hey, thanks. Another quick follow-up for Sarah on that. How did the satellites deploy? I know you said the second stage wasn't completely lost. Was there some kind of emergency deployment command that was sent when there was a problem with the engine, or what happened there? And then for Dana, has NASA asked Russia anything about why its old satellite blew up in space or broke apart in space last month, or has Russia provided any explanation into why that happened? And if so, what was that, and what's NASA's understanding of that? Thanks.
Yeah, so for my question, that's a predefined, I'll say, operational sequence. The stage is programmed to sense either successful completion of the burn or confirmation that the burn has not or will not complete nominally. And then once one of those two things happen, it steps into its next state, which is to deploy the satellite. So it's the same deploy sequence that would happen had it been in the higher orbit, and the predetermined outcome that happens really in any scenario.
Let's see, and to answer the second part of your question, that satellite that broke up had been out of service for quite a while. It was just orbiting. And taking a look at how it broke up, it looks like a pretty typical satellite-type age-based failure. You know, satellites can have any number of issues, especially when they're not in service or actively moving or avoiding things like debris. So, for example, you could get a micrometeoroid strike, and depending upon what you have on the satellite that's still pressurized, whether that's tanks, fuel, other components, you can get a breakup. And so for us, it very much looked consistent with what we've seen with other satellites that can have a breakup. It was when we have something like that that's in the proximity of station, of course, we take very conservative actions until we get enough data and insight about the pieces that have broken off and where they might be heading. So we did have the crew shelter, and then after that, pretty quickly got data and realized it wasn't a big risk or threat to us. But I think to answer your question, it looked like a very kind of typical satellite breakup, so we weren't worried that there was any other kind of explanation for what we saw with that satellite.
Thank you, and thank you all who submitted questions and attended with us here in person today. And thank you very much to our briefers for taking time out of their busy schedules to support this. We do have another briefing upcoming where you'll have the chance to hear from Crew 9 directly. We do hope you'll stick around for that. That begins at 2 p.m. Eastern. You can continue to follow along for more updates on our social media platforms, blog, and online. But for now, that will do it for us here. Thanks so much for joining us.